Have you ever driven over a huge bridge or looked up at a massive wind turbine and just wondered, how does that paint job last for decades against sun, rain, and salt? Well, it's not just paint. It's a high-tech protective system, and it's applied with some serious scientific precision. Today, we're going to peel back the layers on the international standards that make all of that possible.
Right, so let's get into it. This is the big question, isn't it? How do you protect critical, multi-million-dollar infrastructure from literally rusting into dust? The secret isn't some magic paint. It's a magic process, a super detailed, super rigorous procedure that's governed by a global set of rules. So for this explainer, we're going to follow the exact journey an inspector takes. First, we'll talk about why we even need these rules. Then, we'll dive into prepping the surface, applying the paint under controlled conditions, and the inspector's detailed checklist. After that, we'll see how it's all measured, and finally, how it all comes together for a finish that is truly built to last. Okay, first things first. Before anyone even thinks about picking up a tool, everyone involved, from the owner of the structure to the team applying the paint, has to be speaking the exact same language. And that language is written in the standards.
So what is a standard, really? Think of it like a universal rulebook. It lays out the exact procedures, the codes, the test methods that guarantee a project is done the right way every single time, no matter where you are in the world. It's all about consistency, safety, and making sure the thing actually works.
And who makes up these rules? Well, it's a handful of really respected global organizations. You've probably heard of ISO. But in the coatings world, the big players are folks like AMPP, which is actually the new powerhouse formed by merging SSPC and NACE, and ASTM. These are the expert groups that write the incredibly detailed playbooks for the entire industry. For instance, you've got ASTM International. They publish these super detailed documents like the Standard Guide for Painting Inspectors. Now, this isn't some flimsy pamphlet. It's a massive guide that covers literally everything, from checking the steel before you start to signing off on the final job. For an inspector, this thing is their Bible on site. All right, now that we know the rules of the game, we can get to the first and honestly the most critical part of any job, preparing the surface. It might sound crazy, but what happens before the paint goes on is often way more important than the painting itself.
And hey, that's not just my opinion. That is a direct quote from that ASTM guide we were just talking about. So why is it so important? Simple. A coating is only as good as its grip on the steel underneath. If that surface isn't perfectly prepared, the coating is going to fail. Period. End of story.
So getting that perfect surface is a whole process. First up, you've got to do a deep clean to get rid of any gunk like oil or grease. Then you have to physically perfect the steel itself, grinding down sharp edges, getting rid of any little bits of weld spatter, and finally you bring in the heavy equipment for abrasive treatment like blast cleaning to get the exact level of cleanliness and texture that the job requires. And what's really cool is that this isn't a one-size-fits-all thing. The project specs will call out different grades of prep for different parts of the structure. You can see here the main shell and roof of this tank need ST 2.5, which is very thorough cleaning. But the ladder and pipes, they only need ST 2.0, or thorough cleaning. The level of detail is just amazing. Okay, the surface is pristine. Now it's time to actually apply the coating. But again, we're not just talking about slapping on some paint here. This is a scientifically controlled procedure where the materials and the environment are just as important as the person with the spray gun.
Before a single can gets opened, the inspector runs through a crucial pre-flight checklist on all the materials. Are these the right products? The right colors? Are the batch numbers recorded? Has the paint been mixed perfectly? Is it still within its shelf life? Every single one of these details matters. A mistake here could compromise the entire project. And then you have the weather. You just can't paint if the conditions aren't right. The spec defines this really narrow window of what's allowed. The surface has to be warm enough, and this is the big one. It has to be at least 3 degrees Celsius above what's called the dew point. If it's not, you get invisible condensation on the steel, the paint won't stick right, and you're looking at a massive failure down the road. So who's keeping track of all these moving parts? That is the job of the coating inspector. They are the eyes and ears of the entire project, and their job is to observe, test, and document every single stage to make sure it all follows the standard.
You know, the inspector is constantly checking the environment with a whole bunch of gadgets. We're not talking about just glancing at a weather app. They're taking precise measurements of the air and surface temperature, the humidity, and calculating that all-important dew point. The second any of these numbers fall outside the spec, work stops. That's it.
And their checklist goes way beyond the weather. They're checking the equipment too.
Is the abrasive material the right kind to create the surface texture we need? Is it clean? Is it dry? They'll even run a test on the compressed air that's used for blasting to make sure it's totally free of oil or water, because even a tiny bit of contamination could ruin that perfect surface they just created.
So after all that careful preparation and controlled application, we get to the moment of truth. We have to verify the final product. We have to be sure that the protective barrier we just applied is exactly as thick as it was designed to be.
This all boils down to one supercritical measurement: dry film thickness, or DFT. That's the exact thickness of the paint once it's all cured, and we measure it in microns. We're talking 1/1000th of a millimeter. This one number is probably the single most important indicator of whether that coating is going to last for decades like it's supposed to.
Now, standards like SSPCPA2 have crystal clear rules for whether a job passes or fails. A really common one is called the 80-20 rule. It basically says that no single spot can be less than 80% of the minimum thickness or more than 120% of the maximum. See, too thin is obviously bad, but too thick can make the coating brittle and cause it to crack. It has to be just right.
And the way they measure is incredibly thorough. An inspector doesn't just take one reading and call it a day. As you can see here, for any given spot, they take multiple readings and then calculate an average. Why? Because this approach removes any guesswork and gives a truly accurate picture of the coating thickness. No hidden weak spots.
And what happens if a spot does fail? Well, the inspector will then take even more measurements all around that area to map out the exact boundaries of the problem. A non-conformance report gets filed, and a plan is made to fix it. The goal is to make sure the final product meets that standard 100%.
So when you put it all together, from the initial rules in the spec to that final measurement down to the micron, you can see how every single step is designed for just one thing: creating a protective system that is guaranteed to last.
This whole journey really shows the process in action. It's this perfect chain of checks and balances where absolutely nothing is left to chance. From checking the raw steel at the very beginning all the way to that final report, every single link in that chain has to be perfect, and it's that unbroken chain of quality control that gives you a coating built to last for decades.
So the next time you cross a bridge or see one of those massive storage tanks, you'll know it's not just covered in paint. It's protected by a precisely engineered system governed by this whole world of detailed standards, which, it makes you wonder, what other unseen standards are out there working to protect you in the world right now?